Solving for a variable and equivalent equations. To solve for a variable means to write an equivalent equation that isolates the variable on one side of the equation. So we did this some in the last section. So we're going to start by just solving an equation with only one variable in it. And we've done this a lot before. So to warm up, we'll do this again. So we're going to solve for t. T is on this side of the equation already. So to keep things simpler and fewer steps, I'm going to keep it there. And instead, I'm going to make sure to move all of my integers, my regular numbers, to the other side. So I'm going to subtract 4 from both sides, right? Because it's a positive 4 on this side. If we subtract 4, that becomes 0. So 10 minus 4 is 6, and then this side becomes negative 3t. So now we need to, t is not isolated yet. Right now it's being multiplied by negative 3, so we need to do the inverse, which is dividing by negative 3. So we get t equals, oops, sorry, that canceled on that side, t equals negative 2. Now over here we're going to do, we have a similar equation. Look at this. We have our t here, we got our 10, but instead of the 4 and the negative 3 coefficient, we have more variables. But we're going to solve for t, meaning we're going to get t all by itself on one side of the equation. So we're going to do the same steps as we did over here, but we're going to do them with variables. So we're going to start by subtracting v from both sides, just like over here we subtracted 4. So then we have 10 minus v equals, I'll cancel here, negative at. Then we have to get the t by itself. It's being multiplied by negative a, so we're going to divide by negative a. We're going to divide both sides by negative a. So then we get t equals 10 minus v divided by negative a. That can also be written with the negative out in front of the whole fraction, like this. Okay. So now you're going to do these two. So here we are. We're going to, this is only has one variable, so this looks pretty familiar. We're going to isolate the m, get the m by itself, so we're going to subtract 7 from both sides. And we're left with negative 4 minus 7 is negative 11. Now the m is being divided by 3, so we're going to do the inverse, which is multiplying both sides by 3. That's going to cancel, and we have m equals negative 33. Now on this side of the equation, we're going to, or in this equation, very similar to this one here, except for instead of the 7 and the negative 4 and the 3, we have all variables right there. So, but we're going to still do all the same steps. We're going to isolate m. We're first going to start by subtracting t from both sides. Then m is being multiplied by a, divided by a, so we're going to multiply both sides by a. Now here, when we multiply a side of an equation, a whole side of an equation, we have to multiply everything times that. So we're going to end up having to distribute that a to both terms. So that's going to be a times h minus a times t. So here we have solved that equation for n. You might use this in science. If you have a formula, for example, we have a formula, the density of an object equals its mass divided by its volume. Or, to abbreviate, d equals m divided by v. Sometimes you'll want to solve it for a different variable. You want to get volume by itself because you know the mass and the density and you want to solve for volume. And you'd like the formula to be in a very convenient form where v is already isolated. So in this case, v is on the bottom of the fraction. That is not helpful. We want to get v out of the bottom of the fraction. So we're actually going to start by multiplying both sides by v. Dividing by v here and multiplying by v are inverse operations, so that will cancel. And we have v times d equals m. Oops, I didn't solve for v. Oh, I'm just not done yet. Okay, we're almost done. Now v is multiplied times d, but it's out of the bottom of the fraction. That's helpful. So now we just have one more step. We have to do the inverse of multiplying by d, which is dividing by d. So we get v equals m over d. And we're going to solve for m. All right, so m is being divided by v. We're going to do the inverse, which is multiply by v. That will cancel dividing and multiplying by the same number. Cancels to 1. We get m equals vd. Okay, here's another common formula. Distance equals rate times time, or d equals rt. So if you know your speed and how long you've been driving or running, you can multiply the two together to find out the distance, how far you've run. So what if we wanted to solve for rate, for r? We want to get r by itself. Well, right now r is multiplied times t, so we have to do the inverse of multiplying times t, which is dividing by t, which will cancel. And then we get r equals d divided by t, like so. Try this one on your own, but this time you're going to solve for t. And then you're going to try these on your own. You're going to solve for y, so getting y by itself, getting c by itself. This is extra credit if you want to try to get a by itself. And then the next page, we have a word problem. All right, so we have to make a formula. Suppose we bought 2 packs of markers and a 50-cent glue stick for $6.10. Write an equation for the total cost, $6.10. So the total cost is $6.10, using P as the cost of 1 pack of markers. So that's our unknown. A pack of markers is the cost of a pack of markers. But we know how many we got. We know we got 2, so we'd have to multiply that 2 times however much a marker cost. And then we know we bought just a single glue stick, so we're going to have to add 50 cents to however many our cost of markers was. And now we only have one variable. We can figure out how much the markers costs if we just solve our equation, right? So we can subtract 50 cents from both sides. We get 2p equals 610 minus 50 cents is $5.60. Divide both sides by 2. We get p equals $2.80. That's the cost of a pack of markers. Now we have a different scenario. We know that someone bought 6 packs of markers. So instead of 2p, it's going to be 6p. And 3 glue sticks, 3 times 0.5. And paid a total of $18.30. So, same thing. You're going to solve this equation for p. And if you do that, you will find the pack of markers still costs the same amount. It costs p equals 280. So you show your work, and you should get p equals 280. So what we have here, these two equations are actually what we call equivalent equations. And equivalent equations have the exact same solution. The solution for both is $2.80. So let's look at these two equations here. What can we do to the first equation, number 1, that does not change the equality of the two sides to get the second equation? So let's write that first equation. What can we do here so that it equals the second equation? So let's try that out. We cannot change the equality of the equation, meaning the equality of the two sides, meaning we're going to have to do the same thing to both sides of this equation. So if you notice here, we got 3 times as many markers. So let's try that. What if we multiplied this side by 3 and this side by 3? So we haven't changed the equality. We've done the same thing to both sides. Let's distribute that 3. That will give us 6p plus 50 cents times 3 is $1.50. $6.10 times 3 is $18.50. Aha, we did it. So the answer is, what can we do to the first equation? We can multiply the whole equation by 3. And those two equations are equivalent equations. They have the same solution. P for both, the solution is 280 for P. Okay, let's try this one. 2 of the equations below are equivalent to 4x minus 8y equals 16. Circle the equation that is not equivalent. Okay, so we have to think, is there something we can do to this? Let's try this one first. Is there something we can do to our equation to get from here to here? So I'm just going to look at maybe the first term. What would I have to do to the first term to get from 4 to 2? So you might think to yourself, so I'm going to rewrite the equation here. I might think to myself, okay, well, I would have to divide by 2. So if I divide this by 2, in order to make the equation still equivalent, I'd have to divide everything by 2. If we divide everything by 2, what do we get? We get 2x minus 4y equals 8. Aha! That is equivalent. So we're circling the one that's not equivalent. So it won't be that equation. That one is equivalent. We can make a note, is equivalent. Let's try this one here. Now this one has 8y by itself. So let's see what I would have to do. Let's try that one here. I would have to subtract 4 from both sides. I have to get the x term over there. Get negative 8y equals 16 minus 4x. Okay, it's not looking like this yet. This is still negative, so I would have to, in order for that not to be negative, I would have to multiply both sides of the equation by negative 1. Let's see if that gives us an equivalent expression. So negative 1 times negative 8 is 8. Why? We have to distribute that negative 1. Get negative 16 plus 4x. Is that the same as this? Almost, but the 16 here is positive. So this equation, part B, is not equivalent to our original equation. So that is the one that's not equivalent. This one here is equivalent. And your challenge here is to figure out what was done to that original equation. What was done to that original equation to get to that? Okay, and then you're going to try this one on your own here, and you can check my answer key.